Hi friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2614, prime in diagonal. In this video, the point is that we need to check if a given integer is prime. So first I'll read through the problem statement and then we explain the solution. Actually here for this problem is marked easy, and indeed it's very straightforward. So for a slightly harder problem, so you can see the example, that is problem 2507, smallest value after replacing with sum of prime factors. So for the problem here, we just need to, the main point is to check if a given number is prime or not. But for problem 2507, it's slightly harder. So we need to do prime factorization of a given number. So if you have time, you are welcome to check out that video. So here now let's focus on the current problem. So we are given a two-dimensional array called nums. So we want to return the largest prime number that lies on at least one of the diagonals of nums. So here we have this diagonal, so Ri elements right here, or we have this one. The 1, 7, 5, 3, so to speak. Here are two examples. In the first example, so we know in the diagonal, the largest, in this one, the largest prime is 11, right? So 11 is in the bottom right. So in example 2, so the largest one is 17. But you know, notice that if in the diagonals there are no prime numbers present, so we're going to return 0, right? So this is the main problem. So here the nums has a length bounded above by 300. In other words, this is square matrix with number of rows or number of columns bounded above by 300. So the total number of elements is bounded by this number, 4 times 10 to the power 6, right? So basically, this determines the problem size. So with that said, basically we are ready to do the coding. So for the explanation purpose here, first I'm going to write a utility function to check if given a integer, let's call it say n. So let's use some type hint. So we want to check if the integer given n is a prime number or not. So here actually we can assume n is greater than or equal to 1, right? So we are going to return a boolean, right? That's what we have indicated. So now let's look at the coding part. First, if n equals 1, so 1 is not a prime number, so we need to return false in this case. And then we're going to do the iteration. So basically we want to check this n, if this n has other factors except 1 and itself, right? Notice that for this check, we just need to check up to roughly square root of n, because for n, it cannot have two factors simultaneously greater than square root of n, right? You can, because square root of n times square root of n is n, right? If you simultaneously larger than this number, then it will be, the product will be larger than n, right? So for this, I'm going to iterate for I in range. So basically, we are going to start from 2, and then let's write integer. So basically, I will write n to the power of 0.5. Then here, I'm going to write 1, right? So basically, if n modulo I equals 0, right? So it means that n has other factors besides 1 and n itself. So this means n is not a prime. So we're going to return false. Otherwise, so if after the for loop nothing has returned, so we're going to return true, right? It means that the n is a prime number. So here we want to make sure. So here we plus 1. The reason is that we cannot. Some people may plus 2 to make sure the double safe. Actually, here plus 2 is not right. The reason is that if n equals 2, right, n square root basically is 1.4. If we take integer part, that will be 1. If we add a 1 here, we are iterating from 2 to 2. Basically, we have a null for loop. But if we write 2 here, basically 1 plus 2 will be 3. So this range contains one number, that will be 2. Then 2 divided by 2 for sure and has a remainder 0. So in this case, we return the false if we write 2 here, right? So but 2 is a prime number, right? So for the edge case 2, we need to return true, right? That's why here we add 1, right? So here basically you can also just write without 1. But this one is more precise here. Write true. It's not safe, actually. It's not safe. Actually, wrong for n equals 2. So with that said, we finished writing this utility function. So this is the preliminary step. So next, basically, we want to get the diagonal elements and then make some check and comparison. So basically, let's introduce m. This is the side or the number of rows or columns, and then we're going to get the diagonal elements, right? So basically, nums I. So here we write in this format just to demonstrate how to get the diagonal elements, right? So this is for I in range m, right? So now let's use list concatenation. So nums I, so m minus 1 minus I has hinted here, right? If you don't remember. So for I in range m. So this may have some repetition, but it's fine for the purpose of the problem here. What we want to return, so basically what we want to return is max of, so basically we want to get x for x in aux if x is prime, right? In other words, is prime, x is true, right? So here, if this is an empty list, so we should have a default value. So for max, we can have a default value. Here we treat this as a default value using this keyword argument. So here we want to return 0, right? So we are going to do this. So this is one format of writing this solution. Here we use this default to treat the special case in the problem statement. So with that said, let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let's write another solution. So here, let me make some comments. First, basically for this for loop, basically we check roughly square root of n times. So basically the time complexity we will say is O of n to the power 0.5, right, or 1/2. And here actually we used some space. So here space time complexity is O of m. So here m is the size of the grid. So but we treat this edge case with this default value in the max function. So when actually we can easily improve the space complexity. Let me copy this part and give a different treatment. This is actually just at our disposal, right? So after we do this, here let me delete all this, and then we initialize the result. Because if there's no prime on the diagonals, we are going to return 0. So we set 0 here to keeping the edge case in mind, right? And then we're going to do iteration, right? So basically for I in range m. So what we are going to do is going to check if is prime, right? So we're going to check this one, nums II, right? If it's prime, then we're going to update the result to be max result nums II. And also we need to check A is prime for nums I m minus 1 minus I, right? So if this is the case, so we're going to update again the result. So let me copy this line. So put it here and copy this part and to change, modify, right? Then after this, so basically we finish the iteration, similar as here actually. So now we just need to return the result variable. So here this initialization is dealing with the special case in the problem statement, and this for loop is actually basically doing the same here in this list comprehension. So now let's check this version. Yeah, it passes a special case. So now let's look at the generic case. Yeah, it passes the generic case. So with that said, that's about it for this specific problem. So if it's encouraged that you try this problem. So actually the solution to problem 2507 actually gives yields a solution to this problem, because if we were able to do prime factorization, then we can easily check if a number is a prime. The reason is that a number is prime if and only if its prime factorization contains one element, that is itself, right? So with that said, I guess that's about it for this video. Thank you.